But if you take one of these leaves and you zoom in on it, it's the same algorithm. If you take one piece of that leaf and you zoom out, it's the same algorithm, no matter what scale it is. So, the nutshell version of this is that because of these patterns across scale, one of the things that it proved, and we don't have time to go into it, but one of the things that it proved is that not only are we not very good at predicting the weather, it means it actually proved we will never, ever be able to predict the weather. It proved it is an impossibility because of the complexity of the system. There's too many variables. You know, we can know in summer it will be about like this, in winter it'll be about like this. We can give you a range. We can say in 14 days we expect the weather to be like this. But we cannot prove it. And the farther out we get, 1 day out we can be pretty accurate. 2 days out, 3 days out, 6 days out, you know, and by 10 days out, pretty much you're guessing. You know, you're going on historical data. So now, what this has to do with Paul's question is this. Picture a room. Actually, let me look down. Let me redo this. Imagine you're looking down on a room. Here's the transparent ceiling of the room. And you've got a light here, hanging from the ceiling. All right? What I can tell you is this. Here's the radiation point on the floor. Here's the radiation point on the wall. Here's the radiation point on the other wall. Okay, so those are the points on these surfaces that are directly, you know, opposite that light, let's say. What I can tell you is this. I can tell you that that is going to be the brightest spot on that wall. Okay? That's going to be the next brightest area. That's going to be the next brightest area. So I can tell you that there's going to be a circular pattern on that wall gradating out in value. All right? I can also tell you that on the floor, that's going to be the brightest spot on the floor. That's going to be the next brightest spot. That's going to be the next. You see what I mean? So I can tell you that the light's going to radiate like that. Okay?
Those those touch points on the wall, are they similar in value?
What do you think? Good question. Excellent question.
No, because one is further
this one's
away.
brighter.
Yeah.
Why?
Closer.
It's closer to the light. Yeah. See, so you just hit on the problem.
Yeah.
Because look at this. All of this wall is in the light. So even in the corner here, it's going to be pretty bright, let's say. But it's going to be a different distance. If I pick a point here and I pick a point here, those points are very close together, but because they're at different angles and slightly different distances from the light, they're going to be slightly different values, which means one side or the other is going to have a slightly different value. It may only be 4%. But that's why you're going to see that edge.
Oh, wow.
You see what I mean?
Yeah.
So this is, to fully answer Paul's question, what's going on is, going back to our other thing here, when you're getting down here, do you see that there's almost no way those walls are going to be getting exactly the same angle, exactly the same value results because the light's almost, oh, here's the thing. If you take a light and you take a white floor and a white corner and you try and line it up so you see exactly the same values, what you're going to be finding is you're at a 45-degree angle. So the angles are the same on both sides, so the values match, so the edge disappears. But how often does that happen with a randomly placed light? Almost never. So to fully answer Paul's question, the tough part of this is I can tell you how it works, but basically telling you how it works means there's no easy answer. That's the hard part. So you see what I mean? So that's what I meant about the good news, bad news. The good news is I can tell you how it works. The bad news is that's not going to help a lot. You know. Now let me show you one other thing, because this may get you thinking a little bit. And it's not something that I at all planned, but it's worth talking about. So when I taught Art 50, I wanted to kind of get into this stuff, and this is before all these other classes existed. I wanted students to understand the importance of picture making and value and tone and edges, you know, in a design sense, in a 2D design sense. Now, if you take a look at something like this, I had students do designs that were all in line. And when you look at them, do you see how you're not really getting spatial cues? Okay? Now you are getting some focal points like that because of complexity. All right? But then I was also trying to demonstrate to the students how values are much more powerful than value changes are much more powerful than linear things for creating focal points, which is why tonal drawing is so important. You know, so the goal was they had to do a design like this and create 3 focal points and have them designed in such a way that every viewer looked at them in the same order. Now, unfortunately, this guy, his first focal point was this one. Doesn't work, right? Your first one is that one. All right. So then I had them come in and do fills, flat value fills, and it created this. Okay, now it's working. You see what I mean? Now you're going kind of da, 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 which is what he had originally intended. But then I had people add gradations, because this is kind of like the basis of a composition, but then real compositions, paintings, almost always have gradating planes, the atmospheric effects that Carrie was talking about on Monday. Okay? So then they did this.
Oh.
Now you see how much more dramatic it is. Okay, well, and these are high contrast, so they end up feeling very Art Deco-like, which is cool, but some of the other students did some more interesting ones, so I'm just going to click through some of these. So like, oh, this person is kind of cool. This person, you know the Google Doodles?
Yeah.
She's now one of the 8 people who does that, who does those for Google. So it's kind of cool. This is back in 2004. Now, so this was her first one, and her reads were working, you know, but then she put in the value. Now watch what happens though when you see the gradations. You know, and you see how now you're getting these really powerful depth effects? Okay, now there's some even better ones.
Whoa. See if he looks industrial. Oh.
Looks like flour.
Oh. Bad example. Oh.
It's because you guys saw it.
Oh.
When you say it's bad, so it's bad.
All right. Now these are back to the good examples. There's one I'm looking for in particular. Okay. What's interesting about this one is actually, wait, was this the one? Yeah, I guess just some of the subtleties. Look at how some of these edges end up vanishing because where the gradations match up. And actually, Andrea is now at Lucasfilm. She's one of our former Star alums. Anyway, that's it. But do you guys see? So where we're going with this And, you know, is once you guys understand value, once you guys understand gradating planes, once you guys understand all these different effects, when you go to the Cube City piece,
Yeah.
you see what I mean? That's how you create these really intriguing, you know, depth effects and visual effects and drama and, you know, by kind of controlling this stuff in the abstract. But it's really this that you're controlling. It's not drawing, it's not reality, it's design. You know, and making intelligent choices about like, okay, I want the plane to gradate like that, because then I'll get this cool backlit effect. You see what I mean?
It's for animation class or graphic design class?
Well, this was actually when I taught Annie 50 the first semester. That was one of the assignments, was to do something like that. I don't think, they don't do it anymore, do they? No. In any case, that makes sense? All right, let me pull up my notes and go back to the downshitter here. So, you guys, any other questions that you want answered about the, any other questions you want answered about the assignment? Yes?
Can we do a mechanical of a cube, like balanced and resting on the cube? So it's like tilted.
Oh, don't go there. Yeah, I mean, really, it isn't hard. All you would do is do this. I mean, I can show you quickly the concept behind it, but don't do it. Okay? The concept is just this. Okay? That's all it is. You just have a slope. Now, I haven't really talked about slopes, but one way you could do that is in 3D.
Did you use like the auxiliary VP?
Exactly. So you would say, okay, well, I want the next cube to be here. You see what I mean? So that's all you do. Now you do, the reason I don't want you to go there is you get into some weirdness. And here's where you get, and this goes to an auxiliary VP up here. The reason I don't want you to go there is you get into some weirdness like this. And guess what? You're in an aerial view now.
Are you like Joe?
Can you see some examples of this type of stuff with like advanced space concept that we're looking at?
I'm sure you did. I can't remember what it is. But that's basically the idea behind it. And I would encourage you to maybe toy with it in your sketchbook right now. And we'll be talking about this before the end of the semester, but I just don't go there today. Focus on the rendering, get the values right. The mechanics we'll come back to. That's kind of more advanced mechanics. Any other issues? All right, let me try this.